Hey guys, I just wanted to shoot this video really as a follow-up to the video that I just released. And it's in regards to this particular 3.5 gigahertz frequency that they're using in 5G. Now, it's this particular frequency here is really the foundation for 5G to operate on. And it's really a frequency that's been well adopted across the planet. And with this new frequency, there's also coming, I also see some very interesting technological advancements that could be possible with this. And this is really what I wanted to get into today. I wanted to guys just make you aware of some of the stuff that I'm seeing here and some of the stuff that could be, rolled out here as 5G becomes rolled out more across the planet. Now, if you guys look over to the left-hand side of your screen here, you can see I've got an article posted from an organization called GSMA. Now, this is an organization that is really responsible for unifying a lot of the mobile technologies across the planet. And in this article, they're talking about this 3.5 gigahertz frequency and its connection to 5G, and really how they're preparing for new services to run in this mid-band frequency. And you can see here the date. It was done in October 2021. Now, for me, it was I would say probably the springtime, maybe the summer of 2022, which was last year. And this is when I really started to notice this frequency showing up more and more on my spectrum analyzer when I was doing more work for my clients out in the field. And even today, this is a frequency now that has gone completely live all across the city of Toronto, and even a lot of the surrounding cities around Toronto. And this might be the same where you guys are as well. If you live in a city in the United States, maybe you're in Europe or Australia, more than likely you're going to see a lot more activity at this particular frequency here. And in this article here, you can see I've got highlighted, it's actually not a frequency that runs specifically at 3.5 gigahertz. It's actually quite a large range. It's quite a large span of frequencies here. And you can see here it runs from 3.3 to 4.2 gigahertz. Now, this article also states here down in the bottom right, it says 5G networks are also reaching into the millimeter waves for the highest capacity and will use lower frequencies to provide greater coverage. Now, it's this 3.5 gigahertz that really seems to fit quite nicely in the middle here, which means you can still get the capacity with it. You can still get good data rates with this frequency. And at the same time, you can still get a good range of coverage, which means these frequencies can still go through your walls. They can still go through your ceilings, your brick, your concrete, and even things like trees. There's a lot of heavy forests around your area. This frequency seems to respond very well with that. And this is really why this frequency was really selected as the foundation for 5G, because it seems to fit right nicely in the middle here. Now, on the right-hand side of your screen here, you can see I'm showing a cell phone mast with a whole bunch of antennas on it. And if you live in a city, maybe if you live in a city here in Canada, maybe in the United States, you've probably seen a lot of these probably kicking around your city. And here you can also see this is an example of what one of these 3.5 gigahertz antennas might look like. And in the center of the screen here, you can see this is one that's actually been used by Samsung. Now, Samsung is a company that's been very active with this particular frequency range, especially in the United States. And these antennas, what they are, they're smart antennas. And they have some very interesting technologies that work with them. And one of them is actually something that's called MIMO. And what MIMO stands for is it stands for multiple input, multiple output. So what that means is that these antennas, they can send out multiple streams of information, and at the same time, they can receive multiple streams of information coming in. And they can do this all simultaneously. And also these smart antennas, they're actually using a technology called beam forming, which is a technology that can actually target the information directly at a specific site or even an individual that's using a cell phone. So there's a lot of very advanced smart technologies involved in these 3.5 gigahertz antennas. Now, I really wanted to talk about some new developments that are happening behind the scenes here, guys, that I really wanted to bring into your awareness. And it really has to do with the unification of the communications channel with radar technology. Now, the communication channel here, what I'm talking about is really this connection here from your smart device to the internet, or maybe a connection to a phone call or a text message, an email, things of this nature. So this communication channel is something that's always been here, but it's really the convergence or the unification of radar technology into that communication channel. And I thought that was very, very interesting, that this is really what's being developed behind the scenes here already. Now, radar technology is also something that's not anything new. I mean, this has been used for decades. I mean, it's used for, things like the military uses it all the time. And we use it for things like predicting the weather. Like, for example, if there's maybe a low pressure system that might be building in the environment, we could use radar technology to sense that. And that would just give us more awareness as to maybe a storm coming or maybe even a storm building. So radar technology, what it does, it's a very interesting technology. And it really uses short pulses of data. So it's like firing out like little pulses, little information bullets out into the environment. And it's looking for a reflection off the object. So it's trying to sense that so that it knows that there's an object out in the environment. So this is kind of really a very basic description on how it works. Now, if you look here on the left-hand side, you can see I've got an article here, just a very snippet of an article that was done by a group of individuals that are part of an organization called the IEEE. Now, I've talked about this organization before. And what it stands for is it stands for the Institute of Electrical and Electronics Engineers. And this is an organization that's really responsible for developing really all of the wireless standards that we use today. Everything that we're using in 5G, everything that we've been using in 4G, LTE, things like Wi-Fi, Bluetooth. This organization is responsible for really developing all those standards. And in this article here, you can see the title of it it says, Survey of RF Communications and Sensing Convergence Research. So again, it's a sensing radar technology that they're trying to converge together here. Now, in this introduction here, it really outlines what they're trying to do. And I just wanted to read this to you because there's some pretty powerful stuff within this. And it states, the problem of spectral congestion is forcing legacy radar band users to investigate methods of cooperation and co-design with growing number of communications applications. The problem has motivated government entities like the Defense Advanced Research Projects Agency, which stands for DARPA. And for those maybe familiar with a lot of DARPA's work, DARPA is really responsible for really the birth of the internet, actually in its infancy. And it was actually something that was actually called DARPANet back in the day. So DARPA's been involved in a lot of different things. I'm not going to get too much into that in this video, but DARPA had sparked DARPA to begin funding and investigating these methods to not only ensure military radar coverage is maintained as spectral allocation is renegotiated, but to potentially improve both military radar and military communications by co-designing the systems from the ground up. However, these issues extend far beyond just commercial communications and military radar and include a wide variety of applications such as next-generation automobiles, medical devices, and 5G wireless backhaul. As a result, researchers have begun investigating not just methods of military radar and communications coexistence, but more fundamentally methods of joint remote sensing and communications. So here they're saying that's exactly what they're trying to achieve here, is how we can actually communicate over a communication channel, and at the same time we can sense everything within the environment, all the objects that we see in the environment, even things like human beings, which takes us right directly to the article that I have shown here on the right. And this is one that was actually done by an organization called Eurosit. And the title of it says multiple statuses of through-wall human being detection based on compressed UWB radar data. So what this research paper is showing you, they're actually trying to figure out how to detect human beings, like behind physical walls, like things like your brick and your concrete. Can we send these pulses of radar this radar technology, and can we get behind these walls and try and, map out and monitor human beings and all the activity of human beings, which is, again, something very interesting here, because this technology is posing some capabilities here where it can really monitor everything that you're doing within your home, whether or not you're going to sleep, whether or not you get up and make something to eat, go to the bathroom. I mean, this technology has the capability to monitor all that. And in this research paper here, this introduction, I'm just going to read a part of it here because it connects into this 3.5 gigahertz that I'm talking about. It says here, through wall human being detection is of considerable interest to police, rescue, security, surveillance, and anti-terrorism, and so on, it says. Now, I'm just going to stop here just for a second because I always like to look at both sides of things. So again, there's the health and safety side of things, which is what I'm looking at, is are these signals safe for human beings? Do they disrupt any metabolic activity inside the body that we really need to be concerned about? So this is kind of where I'm coming from, but at the same time, I can kind of see where we get some benefits from this. Because to give you an example here, we have to think about an apartment building, for example. An apartment building, maybe there's a massive fire that happens within the apartment building. And the fire services show up, and there's people trapped inside. And we need to get all these people out, but we don't know how many people there are. We don't know where these people are within the building. So with this type of technology, if it's developed, what they could do is they could actually send this radar technology out to sense any human being that might be in the apartment and exactly where they're located, which would give the firemen the ability to go in and kind of make the rescue attempt here. So there is the positive side to this technology. There's no question. And I'm not ignorant to that by any means. And this article continues on here and it says, but wall attenuation becomes prominent, a prominent limitation in the ensuing power budget and object detection. So again, it's these signals going through walls, which appears to be the problem here for radar technology. Ultra wideband, which is short for UWB, radar operates in the baseband approximately up to 3.5 gigahertz. It has the ability to penetrate many common non-metallic obstructions, such as walls, and can also detect, locate, and track the target hidden behind these obstructions. So really right here in this introduction, it's clearly showing what their intention is here. And this 3.5 gigahertz frequency seems to pop up, which is this radar frequencies here, these radar pulses, these very short nanosecond type of pulses that they send out into the environment that operate right in this 3.5 gigahertz. And they're trying to unify this type of technology into the communication channel that already exists. And if they're successful, I think this could really be such a powerful advancement here in this artificial intelligence agenda here. And there's really a lot of unique applications that we could really use this technology for. And really one that came to my mind the other day that was really the most disturbing to me was it had to do with baby monitor technology. Now, I've talked about this in previous videos already. I've looked at a number of products already too, and I've tested a number of different products that are out there. And for me, personally, from my, personal opinion on this, there's not one wireless baby monitor system out there on the market that I feel is safe for any infant to be around. And really the fact that we're moving to this type of unification here with our technologies, this communications and radar technology. And when we look at baby monitors, I mean, this communication channel here that's already there, is that communication channel is what sends out the audio and video data on the baby monitor. So you can hear the baby, you can see the baby on the screen. This communication channel is what's, sending that data. And if we can, if we unify this radar technology, there's a lot of power here on what we can do to really monitor that infant in the environment on so many different levels. And for me, from a health and safety point of view, this just adds that much more risk here, because there's already enough risk with this communication channel that we're using in baby monitor technologies. And on top of that, if we start using radar technology and start pulsing this data at these, these nanosecond pulses continuously within the environment while the infant is there, I mean, now we're just dealing with it's like a double whammy here. We've got an onslaught of two different technologies that could be causing a lot of serious disturbances to, the infant's development here. And for me, guys, this is really a technology here that we really need to pay close attention to here as 5G continues to move forward. And the last thing that I really wanted to mention to you guys here before I close this video out is that, I mean, if you own a smartphone already, and if you own an iPhone especially, if it's an iPhone 11 or newer, I mean, these phones are already starting to use this type of technology. And I found this actually a few weeks ago, and I didn't know this. And I actually have an iPhone that's actually older than iPhone 11. So my phone doesn't have this technology in it yet. And if you look here in this image to here down in the bottom left, you can see here's an iPhone. And these iPhone 11 and newer models, what they have is what's actually called a U1 chip in it. And this chip gives the phone the ability to use this UWB technology, this ultra wideband technology. And here is a definition of that technology. It's an ultra low power, short range wireless technology that can be used to transmit data and capture accurate location and directional information. And this technology can be used for asset tracking within the environment. I mean, your phone now has the ability to really sense its environment in a very powerful way, which means these phones now are going to be radiating these frequencies here, these pulses of frequencies that they never used to do. And I found some interesting information on Apple's website here. You look down here on the bottom right, up at the top it says, Apple didn't bother mentioning this feature during the iPhone 11 release event, which was done back in September 20th of 2019, which is really right before the pandemic started. iPhone released that iPhone 11 model, which has this new technology in it, a very powerful technology, very advanced. You can do a lot of very powerful things with it. And they didn't even bother to mention it during their release event. I thought that was very interesting to see that. It also goes on, it says, but it is noted on Apple's website, as Apple puts it, ultra wideband technology offers spatial awareness. So really what that means is that your phone now has an awareness of what's going on in your environment in a very powerful way. And it continues on here, it says, initially, Apple only advertises one UWB feature. When the iOS 13.1 update arrives on September 24th, AirDrop gets even better with directionally aware suggestions. In other words, you can point your iPhone at someone else's iPhone, and AirDrop will probably know that you want to send things to them. Today, your iPhone just uses Bluetooth to understand who's around you. It doesn't know what you're looking at or where they are precisely. So right now with older models, like I have an iPhone XR, which is a model before the iPhone 11, and it doesn't have this UWB feature. It does use Bluetooth though. And I've done a video in the previous video already to show you, what does your iPhone do when it's on airplane mode? And I use my iPhone, which is an iPhone XR, and I showed you guys that even in airplane mode, this phone is still transmitting Bluetooth. Now, what I'm suspecting, and I haven't done these tests yet, and I really want to. I want to get my hands on one of these newer iPhones, and I want to test some of this stuff. But what I'm suspecting is that now these phones are going to be sending out this radar type of technology here, these pulses of data into the environment so it can sense what's going on. And I'm also suspecting that these pulses of data might be sent out when your phone's on airplane mode. So if you think that you're cutting off all the communication on airplane mode, you might want to, be skeptical of that. So if we look down here at the bottom, it also says UWB technology operates over a wide frequency range from 3.1 to 10.6 gigahertz. Quite a massive range here that this, these newer iPhones have a lot of potential here. And it works best at ranges under 50 meters. So there's a short range with what your iPhone can do here and what it can sense in the environment, which is why there's so much power to try and unify that sensing of position of objects within the communication channel. Because then these antennas here, these MIMO smart antennas, will just have that much more power to really sense what's going on in the environment. And these signals can go long, they can go a long range to, a couple miles in most cases. So there's a lot of power here with what is being developed. But I just wanted to show you guys this to make you guys aware that your iPhone or your Android device is already using a similar type of technology that could be emitted off your phone into your environment. And it very well could be doing it on airplane mode as well. I don't know this for sure, but I'm definitely going to do some testing on that to see. But I really just wanted to bring this all into your awareness because this development here, this technological development that's happening, just holds so much power for what could be possible here with, where our products and a lot of our technologies will go on so many levels, and poses that much more health and safety risk because we have to deal with these constant pulses of data now, as opposed to what's happening on that communication channel. And if we look at a lot of Dr. Deborah Davis's work, she's a scientist that's been studying cell phones and the health and safety behind the cell phones. I mean, she's been talking about the fact that it's not just the intensity of these cell phone signals that we need to be worried about. It's actually the nature of these signals, the pulsing nature of these signals, which could be causing much more disturbing things inside the body. And I want to close this video off here. And I thank you guys for watching.